collision is when two or more objects come in contact with each other, exerting forces over a short period of time. In collisions, momentum is always conserved, however, kinetic energy might not always be. A collision is either elastic if the kinetic energy is conserved, or inelastic if the kinetic energy is not conserved. To visualize this, imagine two balls running into each other. Now, if there's during this point of contact at this moment, if the collision is elastic, then both balls will go their separate ways. But if it's inelastic, both balls will stick together. To better understand collisions, let's look at this worked example. Ball 1 of mass 3 kilograms collides head-on with stationary ball of mass 1 kilogram at a speed 5 meters per second. The balls stick together and travel at a velocity of 2 meters per second. Determine whether this is an inelastic or elastic collision. So first, we're going to want to calculate the kinetic energy before. So it'll be 1 over 2 mb1 times v b1 squared plus 1 over 2 mb2 times v mb2 squared. Now we can plug in all the values. So it'll be 1 over 2, 3 times 5 plus 1 over 2, 1 times 0. So this can cancel out. So it'll just be 7.5 joules. Now the kinetic energy after will be 1 over 2 times m b1 plus b2 times v1 plus b2 squared. We can plug in the values. It gives us 8 joules. Now, since kinetic energy before and the kinetic energy after not equal, that means the collision is inelastic. Similar to a collision, explosions follow the principle of conservation of momentum, which is P initial is equal to P final, which is m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Now, an explosion is where a system that is initially at rest separates in two, which can be expressed by